Hello, Geometry. Chapter 2, Lesson 3, Postulates and Diagrams. This is going to cover when you are given a geometric diagram, what can you assume to be true and what can you not assume to be true with it. And there's also getting into what we call postulates and some rules that are just the foundations and very basics of geometry. Before we get going, I want to redeem myself on the last one. We had a pattern here. I could not quite figure it out, and I finally got it. 2, 3, 5, 7, 11 are all prime numbers. So they are the first 5 numbers that are only divisible by themselves and 1, and they're alternating signs. So the next one would be negative 13, positive 11, negative 13, and the next one it would be a positive 17. So prime numbers, that was what that pattern was there. Okay, so 2.3, and what they're saying is if you have 2 intersecting lines, if this box right here, we know that box to represent a 90-degree angle. But if that box is not there, you cannot assume that it is a 90-degree angle. Okay, so you really have to look at your information to say, okay, what are they telling us, and do I know that that is true? So if we look at exploration 2 at the bottom of page 44, we have a diagram, and the question is, can you determine the things to be true? So I want you to pause the video and go through these examples and see what you think. Okay, can you assume part A, part B, C, and D, and then come back and we'll go over that. So on A, all the points shown are coplanar. That means they are in the same plane. Same plane. Can you assume that to be true? So when you look at this, you can assume that to be true. Yes. No points are shown outside the plane. Okay, you'd have to see one like sticking out over here or something like that to assume that we have points outside the plane. Points D, G, and I are collinear. So here's D, G, and I. They sure look to be in the same line. We can even put a ruler on there and we can say, hey, I'm pretty sure they're on the same line. However, they are not shown to be on the same line. Okay, so we can even stick this on there. It's like, oh, they sure look to be linear, collinear, but it's not what it's stated here. So can we assume they're collinear? No. There's no line shown. And it's 3 points. It's 3 points. If you had 2 points, that would be collinear because through any 2 points, there's one line. But it's 3 here. Points A, C, and H are collinear. Here's A, C, and H. You see they're all on the same line. Yes. There is a line. Can we assume line EG, right here, and line AH are perpendicular? So EG and AH, there's a 90-degree angle, so yes, we can assume that. There's a 90-degree angle. We would not be able to assume that line BD and line AH are perpendicular. Okay? They may look like it, or it could be 89.8 degrees. It could be really close, but they have not stated that. So continuing with that, can we assume BCA and ACD are a linear pair? BCA and ACD, yes. Okay, there's a line right there that makes a linear pair. AF and BD are perpendicular. That is a no. Okay, again, if you haven't done these, pause the video, go through them on your own first. EG and BD are parallel. EG and BD. We cannot assume that. They have not told us that they're parallel. Symbols for parallel lines, remember, are the arrows right in the middle. Not the arrows at the end, but the arrows right in the middle. We'll see a lot with parallel lines coming up. Another chapter. AF and BD are coplanar. Yes, we can assume that. AF and BD, they are shown all in this plane. Can we assume EG and BD do not intersect? EG and BD, no, you cannot assume that. We couldn't assume they're parallel. We can't assume that they do not intersect. Can we assume AF and BD intersect? So here's AF, here's BD. Yes, they're going to intersect at point C. Can we assume EG and BD are perpendicular? EG and BD, no, we cannot assume they're perpendicular. Let's kind of get into the silly side. ACD, ACD right here. Oh, can't see that anymore. Sorry, ACD and BCF are vertical angles. Yes, we can. Those angles are formed by two intersecting lines. Angles are formed by two intersecting lines. That's your reason. Can we assume AC and FH are the same line? AC and FH. All those points are on the same line, so yes, you can do that. Okay, so the vocab here is just a line perpendicular to a plane. That is just a single line that goes straight through a plane, and you'd have to label it if this is plane M. Here's your line. You can label it with a right angle, okay? And usually that bottom one. So that's a line perpendicular to a plane. It goes straight through. So if you have a piece of paper, it's going straight through like that. It's not angled or crooked. It's going straight through at a 90-degree angle. Okay, here's the postulates. Postulates are your most basic, axioms are your most basic geometric term and definition. Postulates are a step up from that. And it's just a fancy way of saying a rule, okay? So the two-point postulate, all these are going to have names, and the names tell you what they represent. So two-point postulate says through any 2 points, there exists exactly one line. You can only have one line through 2 points. So through any 2 points, there exists exactly one line. The line-point postulate is a line contains at least 2 points. So those are kind of converses of each other, so we can make an if and only if, then if and only if statement if we wanted to. A line, you have a line if and only if you have 2 points. If you have 2 points, then you have a line. It works both ways. So 2 points, start with 2 points, says you have a line. Line point says if you have a line, then you have 2 points. Line intersection postulate. If two lines intersect, then their intersection is exactly 1 point. 2 points intersect in one line. You cannot have two lines intersecting and there's be more than 1 point. Okay? These are your reasons kind of over here, your explanation for the example. So line intersection postulate, two lines intersect, 1 point. 3-point postulate. Through any three non-collinear means not on the same line. Through any three non-collinear points, there exists exactly one plane. So that's the saying that we have to have three non-collinear points to make a plane. So any 3 points not on the same line create one plane. So any 3 points not on the same line create one plane. This is kind of the converse here. Plane point postulate. A plane contains at least 3 non-collinear points. Okay, so kind of the converse of that one. If you have a plane, you have at least 3 non-collinear points. Plane line postulate. If 2 points lie in a plane, then the line containing them lies in the plane. A plane line. So if you have 2 points in a plane, the line that goes and connects those 2 points also lies in that plane. Okay, think of the ceiling, the lines in our ceiling, or the floor, or the wall. Plane intersection postulate, this is like the line intersection postulate. If 2 planes intersect, then their intersection is a line. Okay, it's kind of where the wall, 2 walls meet. You have a line going vertical with that. So practice. State the postulate. That means the postulates we're just looking at here on page 46 and 47. State the postulate illustrated by the diagram. So if, tell yourself, what do we see here? If I see points, then what changed? As we go through these lessons, you'll be asking us what's different. Well, the points are still there. What's different is we have a line going through them. So if we have points, then there's a line. So we think about, okay, how does that fit into what we have? If we have points, then there exists exactly one line. So this says 2 points, and we have 2 points. We actually have 3 here. So this would be the 2-point postulate. 2-point postulate. Example 2, if, okay, we have a plane, there's an S, and I have 3 points listed here. Remember, S is not a point, it's the name of the plane. If this, then, okay, what happens here? I have a line drawn, and it's drawn through 2 points. So if I have a plane, and there's points on there, then I have a line in that plane. So that looks a lot like this example that we had right up here. These drawings, these examples can be used as a guide too. So this would be the plane line postulate. So that practice of asking you what's different, what changed, okay, can help you with that. Use the diagram to write an example of the postulate. So example of a 2-point postulate. Oh, which one is that, okay? So we ask ourselves, 2-point postulate. Through any 2 points, there exists exactly one line. So through any 2 points, so here's 2 points, B and C, there exists one line. So I could say one line goes through points B and C. There's an example. One line goes through points B and C. Line point postulate. So I look, line point postulate, a line contains at least 2 points. So we can say line, maybe I'll say line L contains points B and C. So you see how they're kind of similar in the wording there? You don't have to rewrite it well, these you have to would have to rewrite, but it doesn't mean it's completely a new idea. Plane point postulate. So plane and a point. A plane point postulate. A plane contains at least 3 non-collinear points. So I need a plane, here's plane P, and I need 3 non-collinear points. That'd be B, C, and A. They're not on the same line. So plane P contains points A, B, and C. Plane intersection postulate. If 2 planes intersect, then their intersection is a line. So we have plane P and plane Q, only 2 planes shown, and they intersect in line K. So we say planes P and Q intersect in line K. Exercise 7 and 8, sketch the diagram of the description. This is ray RS bisecting segment KL at point R. So we have segment KL, and we have ray RS at point R. So that's bisecting it, so we have to put those marks on there that tells you that each side is equal, and we need a ray. So ray RS is bisecting segment KL at point R. Line AB in plane U intersecting line CD at point E and point C not on plane U. So it's intersecting at point E, and point C is not on the plane. So we have to start with our plane. This is plane U. We have line AB in plane U. It's drawn like this. And it's intersecting line CD at point E, but point C is not on plane U. So I'm going to draw it like this. This one's going up. This one's going down. Point C is not in the plane. D cannot be in the plane, but E has to be on the plane. So line AB is in plane U. It's intersecting line CD at point E. Point C is not in the plane. Okay, last set here. Can you assume this to be true? Planes A and B intersect at line EF. So planes A and B intersecting line EF, that is going right through the intersection. Yes, you can assume that to be true. Points C and D are collinear. C and D, these are 2 points. This is different than our other example. This one is a yes. You can assume this to be true. Okay, because through every 2 points, there is one line. So you can assume that to be true. Okay, that is a ray. Ray HJ and line AD are perpendicular. So ray HJ and line ID are perpendicular. Yes, there's a 90-degree symbol there. You can assume that. Line GD is a bisector of line EF at point D. So line GD, here's line GD, that's in plane B, is a bisector of line EF at point D. Now I'm going to get picky with this. You do not have a bisector of a line. A line goes on forever. If they would have said segment EF, we can assume that. Okay? We can assume that you can have a bisector of a segment, but you cannot bisect a line because a line goes on forever. There's no middle. You can't find the middle. So I'm going to say no on that one. Okay? But we'll put a note here, yes, if this is a segment. Can we assume segment IH is equal to segment HJ? IH, HJ, there's no symbols there? No. That's bad again. This should not be equal, it should be congruent. Okay, final thing, angle HJD, HJD, and angle HDJ are complementary angles. So HJD, this angle over here, and then HDJ, HJD and HDJ, that angle there, are they complementary? Remember, that means they add up to 90 degrees. You have a triangle here, and one of those angles is a 90-degree angle. Remember, in a triangle, there's 180 degrees. So 180 minus 90 is 90. So those two angles have to add up to 90. So yes, you can assume that to be true. Okay, that takes care of 2.3. We're making good progress. Good work. We'll see you in class.